last week. We're building a hearts game, the game you play with playing cards. And this is a little sketch of architecture. We're working on this vertical slice here so that we can get this output. And last week, we did a lot of our work in the hearts domain, which is where our game logic is going to go. And this week, we're going to look at our database access. We're going to put in the code we need so that we can get this times shuffled output here. So if you remember when I described this vertical slice, what I want is every time I refresh the page, times shuffled will bump up. And I want to save that, so if I shut down the application and start it back up, it's still there. Really, this is just an excuse so that I could get some data access into my vertical slice. In reality, I don't think this shuffle counting logic is going to make the final cut. It's probably going to get it thrown away at some point. But I felt pretty confident I would need a database in my application somewhere. And actually, now that I've gotten a little farther ahead, I've kind of finished this vertical slice, but I haven't got all the videos for it yet. I'm beginning to wonder whether that was a good idea. It's probably not a bad idea. And part of the problem is I'm not really happy with what I came up with here, but I also don't want to refactor it because I think a lot of that logic is going to end up going away. But it's pretty decent. It'll give us a good chance to look over something called optimistic concurrency. And it's not bad in the sense that it's terrible. It's just complexity that I don't think I'll need. But some parts of what we do here are going to get reused throughout the rest of our application. So it's not necessarily all throwaway. And honestly, you're never going to get it right the first time. Programming is a very iterative process, especially if you're following some kind of Scrum methodology. So don't try and beat yourself up, pay off your vertical slice and then go implement it. And if you don't like it, then you can fix it down the road in the future. So before we start with our data access stuff, there's one last thing that we have to pick up from our previous work, and that's that we never actually checked in our previous work into any kind of code repository. So that's where we're going to pick up here at the start. I'm going to go ahead and create a Git repository. There's a number of ways if you're working with GitHub. Often people like to initialize the repository first in GitHub and then clone that before they do any work. I obviously didn't do that, so I'm a bit too late here. I'm looking for something to create an initial commit just so I have something. So I want to get a git ignore file in there, so I just Googled for one for .NET Core stuff. And actually for this first commit, what's going to end up going into master, I'm just going to put that git ignore file in there. The rest of this work, I want to commit the whole vertical slice as a single chunk. So I'm going to create a branch for this vertical slice, and I'll commit each video as I do each video. But I'm not going to commit that to master. So go ahead and sign in. I've created the Joy of Programming organization, and I'll create a hearts repository in that organization. So I'll post a link to this if anyone wants to check out the code as we're going along. Coming up with the description is the hardest part of creating a Git repository these days. All the work I'm going to do for this is going to be public, so I don't have to pay anything, and it's all on the videos anyway, so there's no real point in keeping it private. I'm not going to actually create anything from GitHub, just the repository, and now I'll go link it to the code I've got already. I'm using SSH here just so I don't have to type in my password all the time, which if you're streaming tends to be quite helpful. So this is just linking the two repositories. When I call git init up here, it's creating a repository. And when I created a repository on GitHub, it was creating a repository. And now I'm linking the two. So went ahead, checked in the git ignore file, so that is there. All right, now we can move on to the more interesting data access stuff. So all of this data access stuff is going to end up going in a new layer of my application, which sometimes I'll call it the application layer, sometimes I'll call it the infrastructure layer. But this is the sort of outer layer if you're thinking of an onion architecture. It's where I'm actually going to connect to the database, connect to the HTTP endpoints, where I might connect to any kind of scheduling infrastructure. It's where my main method will go and startup will go. And so I'm calling it Hearts app. I'm going to go ahead and add some packages. I know I'm going to need references to Entity Framework. I've got a Postgres library, Postgres database server running locally, so that's what I'll be using today. So the infrastructure layer is different than the domain layer in that it's more focused on just the application. So everything that goes in that domain layer is really just the game logic for the game Hearts. And so if someone were going to create a completely different application and they needed that game, maybe they're creating a desktop application and it's going to be focused on a bunch of different card games or something, they could still reuse that domain logic. The application on logic, on the other hand, is going to be this application, this HTTP server that sits there and has these various HTTP methods and connects to this database. It's not very reusable. And so we want to keep it as far on the outside as possible because it's not very reusable. And we want to reference it only going downward. So this will reference into our domain down below. So I went ahead and created a source folder because I'm going to have a couple different domains or modules or packages, or I don't want to create different projects for each of these, but it's sort of different pieces of my application layer. And data is going to be one of them. One of them is going to be my HTTP access. Those two things are not necessarily related, but I'm still going to keep them in the application layer. So I'm going to kind of stick with one project per layer so far, as opposed to one project per logical domain, just to kind of cut down on the number of projects that I have so far. So I'm creating a DB context here. Entity Framework Core is a great ORM to use. I used Hibernate for a long time, and it was okay. Entity Framework Core is significantly better. I like it a lot better. And one of the nice things, it has that DB context, which is going to be our unit of work. It's also going to have all our repositories in those DB sets. It keeps us from writing a lot of boilerplate code that we might otherwise have to write. So create a test project for my application layer. Now, a lot of my application tests are going to be what people would consider integration tests. They wouldn't consider them sort of pure unit tests, and that's fine. I'm not going to try and argue that they are pure unit tests. Creating this base DB test class here. So this is going to be the base for a whole class of tests, I think, down the road. I've only got one concrete test. And generally, if you only have one concrete and implementation of a base test, I would say it might not be worth it. But I'm very confident I'm going to have more DB tests going down, just from my own experience. So a lot of the things I'll do, I'm just cribbing off of patterns and similar situations that I've run into in the past. And so this is going to be the base for a whole bunch of classes that need to access the database. And its responsibility is to give us access to that database. Now, all these tests are probably going to be slow. That's just a fact of life when you're interfacing with the database. And all these tests are going to be somewhat temperamental in that we want to make sure that they can run reliably. And so we need to get a clean database in between each run. And that's another part of what makes these so slow. Just any kind of database access tends to be slow, but cleaning out the database is slow. These tests will often be order dependent, which is another thing that will anger lots of unit testing advocates. But if you want to do a lot of fast database testing, then being order dependent can come in handy, because what you want to do is you want to clean your database and then run a long series of operations, building up some data as you go and verifying it as you go. And if you could split that into a bunch of small non-order dependent unit tests, but then you tend to go slower. So a lot of the kind of the pure unit testing ideals don't make as much sense once we start moving into integration testing. And I did kind of explain in the last video, which is this vertical slice is not going to have a lot of unit tests because we are building up a lot of our infrastructure layers. We're going to have some end-to-end tests, integration tests, and that's just, they're necessary. I mean, don't shy away from them. So, but we also don't want to try and shove them into the same rabbit hole that we would shove unit tests into. So what I did there, just went ahead and said, truncate the app statistics table at the beginning of every single test. So that's our wiping the database. I wish there were a better way to clean the entire database between tests. So if anyone knows, feel free and let me know. Another common pattern that a lot of people use to get these database tests to go faster is they'll use the in-memory implementation of Entity Framework. And that's not going to actually persist anything to a database. It'll get lost in between each test. But for tests, you don't need to persist things between tests a lot of the time. The problem is that the in-memory implementation of a database rarely behaves exactly the same as the underlying database. So I will end up using it for my other integration tests, kind of functional tests, where I'm testing my use cases and my controllers and things like that. But for actual database testing, where I'm testing repository code and my database access, I really want to be as close to the real thing as possible and not waste too much time writing against an in-memory implementation and then finding bugs at runtime because the in-memory implementation doesn't behave the same way. So what I'm creating here is a app statistics repository. So I did mention that the Entity Framework DB set provides the repository pattern, which is a pattern some people chase after. It provides you a generic repository. It gives you your CRUD operations. But the way I'm going to handle these app statistics, I'm going to do some unique things, and I'll need access that's not exactly just CRUD. For example, this get singleton here. The way I'm going to do this is not, and something actually some database people might frown upon, which is I'm going to create one row for my app statistics, and that's just going to be my singleton app statistics. So I'm not actually going to ever have more than one row of that table. And so then CRUD doesn't really make sense. Create, read, update, delete. I don't want to access it in that way. So I'm creating this app statistics repository to provide the type of access that I need for my application. So I've got this get singleton, which is just going to give me my app statistics singleton. And by singleton, I mean single row in the database. And this is what I'm going to use, for example, when I want to report out my shuffle count. You know, when the user accesses the page, I'll need to grab this singleton so I can go and report it. And I also need to increment the shuffle count. So I'm going to create an increment shuffle count method here. Now, again, we're getting a little bit away from pure database access, you might think, in that incrementing the shuffle count is something that's part of your application. This is not part of necessarily pure database access. But as we'll find out later, incrementing the shuffle count does end up being very tightly related with how we're accessing the data. So I do kind of like leaving it here. And so I've just got this kind of simple implementation where I'm grabbing that singleton. Yeah, I had to fight OmniSharp a little bit here because it wasn't set up initially. I didn't add it to the solution by mistake. But anyway, I'm grabbing that singleton app statistics. It has one integer property on it, shuffle count, so I'm bumping that up, and then I'm saving the changes. That's really straightforward. Not a lot of complicated logic going on here. It's also not going to work, as we're going to find out later. Oh, yeah, just finding bugs that I wrote in earlier. So just want to get this test running now. Yeah, so I tend to use the async access into Entity Framework out of habit. and I'm a little bit less enamored with it now than I used to be. I had kind of initially thought that that async access would allow me to reduce my number of threads, and that C# might be moving more towards a event loop driven server. But the server is still not event loop driven. The server is still a multi-threaded web server. So it doesn't really matter terribly if we're going to use the asynchronous or the synchronous methods for accessing the database. I always have to look up these connection strings, so you'll just see it get pasted in here. You're going to get to see the super top secret password of my local PostgreSQL server. So if you manage to hack into my development machine, that is one less step you need to do to steal the data that I don't really have. As we go further along, we're going to end up grabbing this connection string out of configuration. So environment variables and user secrets, which are more secure. Generally, you never want to be storing passwords into a GitHub repository. This one's not terrible because it's just a password on my local development machine, which is not really exposed to the internet in any way. So I'm not terribly concerned about that password getting committed. But still, just for cleanliness sake and consistency, we will eventually replace that connection string with something that we're getting out of configuration. So let's go ahead and write our test here. And it's going to be pretty straightforward. I managed to confuse myself a little anyway, even if it's straightforward. But we're going to grab an instance of that app statistics repository, and we're going to call increment shuffle count on it. You will notice that a lot of the code here is a little bit verbose because Entity Framework and ASP.NET Core are very heavy on dependency injection. So a lot of repositories that you'll see are going to maybe not be built with so much dependency injection in mind. But this tends to be a lot cleaner at the end of the day, easier to test. But we do have a little bit more work creating a lot of objects. And so what I mean by that is, I guess it's still dependency injection, but if you're thinking Hibernate, you often have the, it's been so long I forget what it's called, but you have sort of this thread local singleton that everyone is accessing. And so you don't have to inject it in all of the time. Whereas ASP.NET Core, Entity Framework Core, avoided thread local singletons by using request scoped dependencies. And what that means is every time I create a hearts context, I'm creating something that is not thread safe. And so every time a web request comes in, I'm going to create a new hearts context that's going to survive for that web request. And in fact, a web request may even have multiple implementations of hearts context, depending on what it's doing. That would be if you were going to, for example, start processing the request, and then you need to do something slow, like make a backend call or wait for some scheduled operation or some bulk operation to finish. And then you might create another hearts context or DB context to do kind of the cleanup after the fact. But these DB contexts should not be very long-lived. Typically, they survive the length of the request. You don't want a context per operation. And this all comes back into the unit of work pattern. Where are you going to define your unit of work? And the nice thing about building web applications is unit of work per web request is almost always the right answer. Or at least it's a very good answer. Anyway, I managed to finally run my test, and I say, oh, there's no actual row in the database. When I call get singleton, that's not going to work. So the way I'm going to solve this in my eventual application is using seeding, database seeding, to create that first app statistics repository or app statistics row one and only one time. However, that database seeding logic is going to be outside of all of this app statistics repository. That's going to be back in our application layer. We're going to build that later. So for right now, for this unit test, we can just go ahead and in our constructor, make sure we create at least one row. So it ran, and right now it seems like everything is fine. But there's one problem, and that's we're building a web request. And so there's no real guarantee that we're only going to have one person using it at one time. With desktop application, you can usually get away with that. For building a web application, we could have multiple users that are pulling up. No, I mean, we're not building anything terribly exciting right now, so I don't think we're going to have a ton of users, but we should plan for that. We could have multiple users that are pulling up those shuffled decks. And so we could have multiple requests coming in at the same time, and we could have multiple threads trying to increment the shuffle count. So I'm going to expand my test here, and we're going to try that out, where instead of just grabbing an app statistics repository and incrementing the shuffle count, I'm going to create 10 threads, and they're all going to try and increment the shuffle count at the same time. And so let's think about what's about to happen here. Each of these threads is going to get their own context. In my task here, each thread is going to be running this increment task. They're going to get their own context. That context is going to then query out the app statistics row, that one row from my database, increment that shuffle count, and write it back in. Well, all of these are going to get launched at roughly the same time. Pulling that row out is kind of slow, so even though I only have 4 cores, all 10 of my threads are probably going to be able to pull out that row before anyone else gets a chance to finish. And so what you'll end up finding is that they're all going to pull out that row, and they're all going to get that initial value of the row where the shuffle count is 0. And they're all going to increment that to 1, and then they're all going to save it back out. And so what I expect that I'll see here is that the shuffle count will end up being 1 and not 10. Ideally, if I have 10 threads come in and they all call that increment shuffle count, I would get 10 as my shuffle count. And I don't actually get 1, I get 3. So it seems that maybe a few of these are finishing before some of the last tasks get kicked off. That's not terribly surprising. I don't even have an SSD, so I was expecting it to be slow enough that I would still get that 1. But 3 is not surprising. Either way, it's incorrect. So now we have to think about how we fix that. When we have concurrent database access, there's 2 approaches that people are always going to start talking about. They're going to start talking about, I'm going to pause this for a second so I can explain this. Actually, no. Let's talk about that in a minute. Before we get there, I want to get a better understanding of what's going on. So I'm going to add in some logging here because I want to see what is the SQL that's actually getting sent down to the database. What's actually going on here? So I need to set up logging. Again, logging in a unit test is something that, purist unit testers will complain about, but for an integration test, it's fine. So what I want to do is something I've done before. And again, I'm often cribbing from patterns that I've already implemented before. And I'm going to set it up so that every single unit test will log to a file, and it's going to log to its own file. So I'll have 1 file per unit test. This is kind of handy if you have 50 unit tests and they run and one of those tests fails. You'll often want to go look at the log for that one test that failed and try and figure out what's going on here. And I keep saying unit test. Again, we're talking about integration testing here, but I'm going to call it unit test just because it's a automated test run with a unit testing framework. So I'm setting up logging. Eventually I'm going to be using ASP.NET Core to run this application, so it kind of has some built-in code to use the Microsoft extensions logging. The built-in Microsoft logging stuff is great, I like it, but it doesn't have any ability to write to a file. It can write to a console, it can write to like application insights and a few things there. But I really do want to get that file output. So I'm using Serolog instead of the built-in Microsoft stuff. Serolog has some adapters to make it look like the built-in Microsoft stuff. So I've got these 2 instance variables here, the logger and the logger factory. The logger is the Serolog concept, and the logger factory is the Microsoft logging concept. Microsoft has this logger factory, which is usually what you're going to put in your dependency injection container. And then anytime one of your services needs a logger, it will use the logger factory to create a new logger for that service. And the reason they do that is so that each logger can be namespaced, usually according to the class. It's something a little bit unique to ASP.NET Core. Usually you see static loggers in a lot of other places. But the way Serolog implements that logger factory is they have you set up one logger, essentially, which is going to be used throughout our application. And then the logger factory is just going to give you different views into that logger, which set up the logging context in a certain way. So most of what I'm writing right now is just kind of your stock Serolog configuration. Set the minimum log level to debug. If you set it to debug, Microsoft is going to log out a ton of information that you probably don't want, so we set Microsoft information. Enrich from log context, that's going to add that log category, which is going to get set to basically the name of the class. And we're going to write to our file name, which up here we calculated based on the name of the test. We also go ahead at the beginning of the test, we delete that log file if it already exists, and then this create logger will recreate that log file. So we get all that set up, and Serolog logger factory is our Serolog to ASP.NET Core adapter, and then we pass that in when we're building the database. This gives the logger factory to Microsoft. Oh, I've also created another base test class here. So now I have DB test and I have base test. So base test is what's providing my logger. All of my application tests, which are really all going to be integration tests. All of these integration tests are going to need loggers. Only some of them will need a connection to the database. All right, I'll go ahead and kick off that test. I realized that I forgot to save a file. Actually, it takes me a little while to realize that. And Entity Framework has some pretty nice logging where it's going to show us what SQL statements it's kicking off. For DB tests, that's really helpful because when you're writing these complex queries or efficient ways of bulk operations or storing data, you really want to make sure that you're running the SQL that you think you're running. And so having that logged out so that you can take a look at it is very helpful. I hit the wrong button, so it tried to launch something and that didn't work. And now I got a little bit confused because I was trying to find out where it actually created that log file. It took me a while to remember that I'm doing path.combine logs. This is going to be relative to the working directory. I had thought the working directory was set to the project. I forgot that the working directory is actually set to where the built DLL gets sent. Eventually, I'm going to figure it out here. Okay, so I finally find that log. And now I can see all the SQL that's actually getting kicked out. And we can kind of see what I was describing before. We have all the selects sort of running, and then a few of the updates and some of the selects, and a few of the updates and some of the selects. And so the selects are all running before a lot of the updates are completing. And then, so they're all reading back 0 or maybe 1 or 2 for some of the later ones apparently. And then the updates will run and they'll all kind of save. So that's not working at all. So now we can think about how should we fix this. It turns out when we talk about database concurrency, there's two things people are going to jump to. They're going to jump to pessimistic concurrency and optimistic concurrency. Pessimistic concurrency is where you're going to assume that something is going to go wrong. And so you want to use a lock of some kind to lock the data that you're about to modify and block anyone from trying to modify it while you get your changes in there. It's called pessimistic because you assume that something is going to go wrong, and you do work every single request. Every single time you run into this critical section, you're going to do work grabbing that lock, extra work to make sure that it goes through smoothly. Pessimistic concurrency is actually somewhat frowned upon and not terribly popular. Part of the problem is that there's no SQL uniform method for doing this kind of locking. It tends to be different per database server that you're using. And there's no real standard way of doing it. One of the symptoms of all of this is that Entity Framework Core has no capability for pessimistic concurrency. So that option is kind of off the table anyway. You could go into the database and you could do native SQL statements and get locking specific to PostgreSQL, and that might not be a terrible way to do this. But we're going to look at optimistic concurrency instead, which Entity Framework Core does have some logic built in for. And optimistic concurrency is where you assume that most of the time you're not going to have a conflict, but you sort of do a double check when you're saving to see if someone updated or changed the records that you're about to update since the last time you read them from the database. And so the way we do that is usually you have some kind of version column. I'm just going to use the shuffle count column here. But you have some kind of column that becomes your concurrency check column. This is just called version in Hibernate. Different ORMs will call it different things. But essentially we say, when I read my statistics out of the database, there's going to be some shuffle count. And when I go to write my statistics back to the database, I expect that that shuffle count is the same thing that it was when I read it out of the database. And if it isn't, then someone has gone in and modified that row before I got my chance. So let's go ahead. Just by adding that concurrency check attribute, we rerun our test, and now something very different happens. We don't get 3. Before we didn't get an error, we just had the wrong data in the database. Now we're actually getting an exception when we're trying to run our code, and the exception is database operation expected to affect 1 rows, but actually affected 0 rows. This is an okay error message if you understand optimistic concurrency. If you don't understand optimistic concurrency, this tends to be a terrible error message, and this is something that is Googled for incessantly. I don't know why they didn't come up with a better one, because Hibernate had pretty much the exact same error message, and that was one of the most Googled for things on Stack Overflow, is what in the world that error message actually means. It gets a little better as we go on. Data may have been modified or deleted since entities were loaded. So now if we have at least a little bit of an understanding of what optimistic concurrency is, we can kind of see what's going on. This is telling us that someone updated your data. And if we look at our log now, we can actually see a little bit better what's going on. So before, when we were doing our update, it was saying update app statistics, set shuffle count where ID equals blah. And then it was just ending right there. There was no and shuffle count. Now, when we added that attribute, it added to our update query and shuffle count equals P2. Because what's happening is we read this row from the database, we read in that shuffle count, and let's say it's 5. Then when we go to update, we're going to say update app statistics, set the shuffle count to 6, where the ID is 1 and the shuffle count is 5. If no one has gone in and modified that in the meantime, this update will go through. And in SQL, whenever you do an update, you get returned back the number of rows that were affected. So it'll say, oh, 1 row was affected. However, if someone has gone in and modified that shuffle count already, it's going to be 6, not 5. And so this where clause is not going to match. It's going to say where ID is 1 and shuffle count is 5. Well, no, the shuffle count is 6. So it's going to return back that 0 rows were updated. And that's actually the meaning of this error message we get back here. What it's saying is that operation was expected to affect 1 row. We expected the update operation to return a affected rows count of 1, but it returned an affected rows count of 0. That's how optimistic concurrency works. However, that is not, oh boy, any better. That's not solving our problem. An exception is not what we want. Now, sometimes with optimistic concurrency, an exception is fine. It's good enough. What you can do is you can just throw that exception all the way back to the user and say, hey, other people were trying to access it at the same time. Maybe try again later. Sometimes that's fine. Usually, if you get that error message as a user, it's frustrating. It's okay to do that if, for example, you wouldn't really expect two people to be accessing the same data anyway. We throw that check in there just in case, so that we're not doing anything too bad. But like if you think of if a user's updating their user profile information, they're updating their password or their email address or first name, last name, something like that, you really wouldn't expect two web requests to come in at the same time to update that information at the same time, because you probably can fairly expect that you're only going to get one stream of web requests per user, and they're not going to be simultaneous. To get that, you'd have to have like two browsers trying to operate on the same user object. That would be pretty unlikely. And so there, maybe it's fine to just throw that optimistic lock exception. However, sometimes you want to throw back something to the user and say, if a user was actually trying to update or modify some kind of form, like let's say you had some kind of scheduling application and they changed the details of an event and they want to save it, but someone else had come in and modified that event beforehand, then what you often want to do is you want to pop back up to the user and say, hey, someone else has tried to modify this. You need to resolve this conflict somehow. And you can do some kind of merge conflict resolution. That gets really complicated. A third approach that you'll often take with optimistic locking is say, oh, well, I'll just retry the operation with updated results from the database. And that's actually going to work for our shuffle count here. Because really what we want to do then, if we hit this issue, is say, oh, someone modified that row? Well, let's just go in and let's read out the latest value of the shuffle count and let's try again. And this works. And if you don't often have concurrent access, it can be okay. If you do expect that you will have a lot of concurrent access, and for something like this, again, it's kind of hard to think about because this is probably not going to be part of our actual application. But we could expect that there might be a lot of concurrent access. And this kind of optimistic retry is not a great solution because it tends to not be very fast. And we'll see that coming up here. So .NET Entity Framework Core has in its optimistic locking documentation kind of a little example they walk through of how they do this sort of fix. And it's a little bit ugly. I don't like the complexity that we end up with here. And I'm really not a big fan of the APIs that are here. It gets fairly low level. This is kind of the ugly side, the ugly underbelly of ORM that is maybe not seen in a lot of your ORM is so great and easy, here it goes tutorials. But what we're going to do is I'm creating this static method here to kind of encapsulate this retry logic, because otherwise you end up writing the same logic again and again and again. And basically what we're going to say is, okay, I'm about to do something. I know this thing might trigger an optimistic exception. If it does, then I'm going to try and repair and then save again. So we're going to do this while true here loop. And I was thinking later that while true might not actually be the best approach. I should probably say while too much time hasn't elapsed. And I am going to do that, but I still end up with while true. So I could write this a little bit more cleaner and easier. But I do record the start time because I don't want to try forever to save the database. And actually, what can happen sometimes if you're using ORM in a fairly complex way or in a simple way but wrong is you can actually trigger a concurrency exception on yourself and through a bug in the code. And what will end up happening if you don't have some kind of break in this logic here, you'll end up getting stuck in this infinite loop because every time you try, you're guaranteed to get a concurrency exception because you're triggering yourself somehow. So we're going to put a timeout in here, some kind of failsafe. Anytime you have a while true loop, you should have some kind of failsafe. And so what we're basically saying is we're going to try and save our changes. And if they actually saved, great, we're done. If they didn't save and we got a concurrency exception, well, let's look at how much time has passed. If too much time has passed, then we're going to give up anyway. That's our condition where, I'm saying it's 30 seconds here, it's pretty long. If we spend 30 seconds trying to save this data, then either we have a bug or we have some underlying problem, because it should not take 30 seconds to do an operation. However, assuming it hasn't been 30 seconds, we're going to go ahead and try and repair our state, and we're passing in this ex.entries. Turns out in Entity Framework Core, when you get a concurrency exception, part of that exception is kind of this is essentially what it was trying to save to the database. So we can go in and we can kind of try to repair those entries. And it's not pretty. And also what I want to do is I want to go ahead and log a warning. Even if I end up later succeeding, I still want to go ahead and put some kind of warning in our application log, just because this is, can be a sign if you start to have a lot of this concurrency that you're getting to the limits of your scale, or that you need to fix your access somehow so you don't have so much concurrency. When you start to see a lot of these concurrency exceptions occur, it could just mean that your server is starting to get overloaded. It's a good warning sign. In general, you don't want to be having a lot of these things. If you have a lot of these things, then either you're getting close to your scale, or you've implemented your data model in some way that is leading to the excessive concurrency, and you should probably fix it in a better way, either with pessimistic concurrency, and the problem with the optimistic pessimistic is it's a bit of a false dichotomy, or just find some way to rewrite your model so that you don't have to have that concurrency, or you can put in, maybe you can put in some locks in your application to reduce the amount of concurrency you have, so you can have some process level locks. Now, downside with process level locking is if you have clustering, then you're still going to have that eventual database concurrencies. What I mean by that is, if I have a web server, I could use a lock object using standard C# locks to ensure that only one thread is accessing that particular critical section. But that's one thread for that database server. If I then scale horizontally, where I have 5 or 6 of these application servers, each of those would have one thread, and so I would still have concurrent access to the database itself. All right, now here's where I'm calling in that logic I just wrote, and I'm doing that repair operation. And as you can see, it's fairly ugly. And you'll notice this first thing here that I'm doing, var db values equals await entries. The await is always a good sign that you're about to be doing something slow. What this is going to do is it's going to try and save to the database. It hits the exception. It comes up here. This await is actually going to trigger another query to the database to say, okay, well, what is the shuffle count? It wasn't what I expected it to be. Someone changed it under the hood. What is it now? And once I figure out what the shuffle count is now, I'm incrementing that value and trying to save that value instead of what I was trying to save before. And here's another reason I don't like this implementation I came up with, because you have kind of that same increment in 2 different places. I don't like it because I have this accessing the map with the word shuffle count and not the property. There's a couple things I don't terribly like about this, but this is part of the code that I'm pretty confident is going to go away. And if it doesn't go away, if this does become an essential part of my application, I'm probably going to come in at some point and fix this in a much better way than optimistic locking. And for something like app statistics, another pattern that works really well, which we're not going to see here, is to keep in memory your statistics, and then just anytime someone comes in and increments something, you're incremented in memory, and you have this other thread that's in the background saving it whenever it gets dirty. And it can kind of handle those concurrency exceptions as needed, but you don't block your actual request on this dirty save. All right, so throwing in some code here to go ahead and build the logger. I ran into a problem because it's an extension method, and it took me a little while to figure out what the right import was. Okay, so let's go ahead and pass in this logger, but pretty much that's what we need here. I think there's still one bug, which we're going to work through here. But I've got that logic in. So now I try and save it. I try and increment that value. If I hit a concurrency exception, one of these optimistic concurrency exceptions, I'll read back the actual value from the database. I'll increment it again, and I'll try and save it again. Yeah, so I hit that exception again. This one took me a little bit of time to debug, but that's hidden here. I I'd forgotten to get rid of my old call to save changes. This save changes with retry is going to call save changes under the hood. So got rid of that old call. And now it runs and it passes. So now we have a thread safe incrementing of statistics into the database. Is it good? Well, let's see. Let's go look at our log again. Now we're going to see a lot of selects and then updates, and then we have to call a select again to get that latest value, and then we try and update again. But oh, we still have some more concurrencies. We have another exceptions. We start get these blocks of concurrency exceptions, and they get smaller and smaller and smaller. But I'm going to do a quick search here. There are 36 update statements when I should have only needed 10. And there's probably twice that many, probably 70 something select statements, when again, I should have only really needed 10. So this is terrible for my performance if it's happening often. This is a test. So maybe in the real application, I'm not going to have 10 threads concurrently trying to increment my shuffle count at the same time, and this is okay. Again, with performance, you can just, this can't be considered a performance defect until you have a performance requirement. And even if I had, 50 concurrent users, I can't even begin to think of how I would create a performance requirement for a slice this thin. So I'm not going to beat myself up about it. But that is one of the problems with optimistic concurrency is if you're optimistic when you should have been pessimistic, you'll end up paying a performance penalty because you have to redo things over and over and over again. All right, let me go ahead and clean up that test name, and then all that's left to do is push this code that I've done into Git. As I mentioned, I'm going to go ahead and create a branch for this whole vertical slice. And I'm going to commit at the end of each of these videos. You'll notice here I'm not going to use a very clever commit message. I am the type of person that will create a feature branch and then make a bunch of dumb commits to that as I'm moving back and forth between different machines. That happens a lot. I go to work, come back, work on my laptop at home. I'll just put in some dumb commit message and then I'll squash it all together at the end when I do my final commit. So I'm just going to say work in progress. All right. Anytime you create a new branch, you have to set it up to track the branch from origin, unless you create the branch on the origin first and then check it out here. But we're done. So thank you for bearing with me through that overly long video this week. Future weeks should be considerably shorter, and I'll be making sure to try and cut back how much code I'm tackling each week.